Okay, we are live now. So thank you very much, Joshua, for coming to the meeting. So I would like to give a brief information about the our audience. So this talk will be with Joshua Miller. He's an expert in BIM for fabrication. We will talk a lot of interesting topics. In fact, there will be lots of topics about the VDC and BIM, the commonalities and the difference between them, some BIM advice, but also mass timber construction, as well as fabrication for a BIM and what kind of techniques he has been using in the industry, and going some to details a little bit more into professional aspect of it. So where we hear a lot of theoretical topics about the BIM, but it's very important to understand also the practical side behind what kind of difficulties he's facing with and how he's overcoming these challenges, and maybe like his pain points in the industry and what he's looking for in the future and how he thinks that it will evolve. So there are going to be lots of interesting topics, and Joshua, I will let him to introduce himself as well a little bit more deeper, so you understand his background and what he's practicing exactly. So I'm giving you the word, Joshua. You can just move on with introducing yourself.
Sure, yeah. So yeah, my background is in construction. I've been working in the construction industry for about 15 years now. I've done a lot of different things. I was a carpenter, I was an electrician out in the field, and then, got into construction management. So I was doing a little bit of project management, and then got into BIM. So got into BIM modeling and coordination, and that turned into a role with VDC, and then that kind of morphed into working in mass timber, but also working with other structural systems, so structural concrete, structural steel. So that's kind of my background, a little bit more in depth, and yeah, it's an interesting field within BIM and VDC is BIM for fabrication. It's a little bit it can be intense, so it'll be
Absolutely.
fun to talk about that too. Yeah.
And how many years of experience do you have, and what kind of projects you're involved? Just can you give us a brief idea?
Yeah. So as far as BIM modeling and coordination management, it's been about 5 years since I began doing that. But I started in the construction industry back in 2008, so it's been quite a while. I think I said 15 years, but I guess it's not been quite that long. As far as projects working on, I've worked on a lot of different things: hospitals, schools, airports, multi-family housing, single-family housing. Yeah, I think that kind of covers it. Yeah.
Was it all for fabrication? All fabrication?
Yeah. Yeah. So I worked on the Portland, Oregon airport renovation. Worked on some community centers in Oregon. So event spaces, gymnasiums, basketball stadiums. I've worked on libraries, hospitals, like I mentioned. But yeah, this was all designing for fabrication, prefabrication.
That sounds really interesting. Okay, so just to understand a little bit more of the complication of the projects, can you give us like from the cost point of view, what was the cost involved in the projects? Maybe like one of the largest projects you were involved, and how many millions?
Yeah, so the largest project I was involved on was $3 million, but that was just our portion of the project.
No, I mean like total project cost.
Oh, the total project cost. Gosh, yeah, this was.
It's a tough one.
Yeah, I think it was, gosh, I think it was $350 million for that project, and then our scope was $3 million of that portion. So that was an airport, so it was quite a big project.
Okay, I see. So actually, I think the sound might have interrupted. Can you just again repeat the number? How much it was?
Oh yeah, so it was around 350 million, I think, was the total cost. So that's the biggest project I've been on.
Okay, all right.
So mostly I'm working on smaller projects.
And what about the small project cost? So what kind of costs you have been involved? Like the smallest one?
The smallest one, I think, was just $500,000. Very small.
Yeah, it's very project. Small. Wow.
Yeah, kind of. Yeah. So that was just a single level renovation of an office building in downtown Seattle. And so, yeah, very small project. We only were doing just a handful of things. I think I worked on the project for maybe 3 hours, and then that was it. So that was the
Okay.
smallest one.
Okay.
Yeah.
So I think there's, let me just double check 1 second. The like we will be discussing, obviously we are doing it for the first time, by the way, this live thing. So, and I didn't apologize from the guests yet, because last week that's what we were discussing, like with Joshua last moment, that we did something happen. I mean, something is happening with my computer. I don't know why. So there are always some notifications coming up. But last week I had a very bad cut just before the meeting, just before this live talk, and first time we are doing it. So I appreciate that people actually took the effort and coming this week again, even though we postponed it, because you never know when it's live talk. You never know what's going to happen, and last moment anything might happen, right? So. It's a really great example for the industry to see that BIM is not only like people dedicated to BIM themselves. They don't necessarily have to work a $300 million project or $500 million project. They can actually work on smaller projects. The most important thing is that the value that you can bring, and value can be brought to the smaller side of projects, which is very difficult in the industry to explain to the people why. How you can afford to invest in the small type of projects. I really understanding I think what kind of value BIM can bring to the table in comparison to traditional methods. So can you give us a little example, and before we jump into deeping topics, what do you think that BIM, how do you think BIM can bring benefits to the table for small scale projects?
Yeah, so I want to talk specifically about that small project I just mentioned. So it was a one level of a commercial office space that was being renovated for a client. And yeah, I mean, typically on a project like that, you wouldn't see any BIM. But because we were involved with the mass timber, so what was happening was that they wanted to install kind of a mass timber canopy. So there were wood columns and beams coming off of the elevator shaft, and it was going to be like a small gathering place for people within the office. So the way that we manage our process is everything is prefabricated. So everything is cut offsite and then shipped to the site and installed. So we have to do BIM modeling and management in order to deliver our product. So we went into the space and it was just very simple. We had one of our carpenters go out and do some field measurements and basically mark up a PDF with photos that he took and measurements. And then I took those things into the BIM model, did all the BIM coordination, modeled all the walls that we're going to be framing into the mass timber elements. And I think it added a lot of value because, it was a difficult project because we had to bring all of our stuff up the elevator. So we had to make sure everything fit within the elevator. So I actually modeled the elevator to make sure that all of our beams and columns would fit in the elevator. And like I said, I only spent maybe 3 or 4 hours on this project, but it added a lot of value because the installation only took 8 hours because they were able to just take everything up the elevator, install it in place. I think it was a really great resource for the project because typically on a project like that, what you would have is someone out in the field, like a superintendent or a foreman, who would be just measuring things and marking things on paper, maybe marking up PDFs on his computer. But because we're developing a model out of those dimensions, we have to think less about the project. We know that all of those dimensions are captured somewhere in a piece of geometry in a model. And so there's an assurance that when it gets to the site, it's all going to fit into place. And we're not going to have to recut or anything or move walls or, things like that. So it was a lot of
Actually, you make very good points, to be honest.
Yeah.
So, because when you have everything object-based modeling, you can really make sure that everything fits, like within the elevator, and you can easily extract all the data. The question over here is that you already have BIM implementation and BIM workflow in place. So that's why it was straightforward for the project. It already brought the value directly to the project, both to the client and both to yourself. So, when you don't have BIM implementation, what could be the challenge in that case? Do you think that it's worth it for such a project, or it's better just to have traditional means and not to implement for such small projects BIM?
Yeah, I think it depends on the complexity of the project, obviously. But I think one of the problems that we're facing within the construction industry is the lack of skilled workforce, right? So, where there might have been an assurance in the past from the design team and the owner that the drawings would suffice to give people the information they needed to put the project together, what architects and engineers and owners haven't seen in the past is how much problems get solved in the field by these skilled laborers or superintendents that have been working in construction for 30 years. And that's going away. That's no longer the case where well, I mean, there are still very skilled people out there, but they're fewer and far between. And so I think it really does benefit a small project, especially if you have a shortage of a skilled workforce, right? So I think if you are a contractor working on a small project, I have another story if you want to hear this story.
Yeah, sure. Go ahead.
So this is a story from a casino that I worked on, and we were the general contractor, and we had maybe 20 or 30 subcontractors, and one of the subcontractors was a stone and masonry, but they were doing all of the floors. So all of the floors in the casino, well, the main raceway was stone tile, and then there was like a central bar that was stone tile. Well, what had happened was whoever installed the bar, so the bar was a prefabricated element, and it was shipped to the site and assembled as part of the kitchen, the kitchen and special construction subcontract. But what happened was that the central bar was prefabricated, much larger than the plans had specified. And so all of the tiling work because what they had done was they had pre-cut their tiles off-site to be installed around the bar, but all of a sudden they didn't work, they didn't fit, and they couldn't figure out how to modify the tile without buying new tile. And so we, as a general contractor, and this is before we had BIM implementation in our company. I was the only one who knew how to use BIM.
When it was happening, what was the, like, how many years ago?
Yeah, this was back in 2016. So it's 5 years ago.
Okay.
So, so the stone subcontractor didn't know what to do, and so I just got on the computer and modeled the kitchen bar, and then I modeled the tile, and then I just gave them drawings on how to recut the tile based on the new dimensions of the bar. So, I think it is worth it. Even if you don't have a BIM program within your company, it's still really valuable to have a person on your team who knows how to use the tools, even if it's just a very small, specific use of that tool. Another example was the architect decided in this casino that they wanted this specialty TV mount made, where 4 screens could be mounted on a single pole. And so nobody really knew how to do that. So we jumped in and made a BIM model of a pole, and we had it fabricated and brought to the site. So, even if you don't have a BIM implementation program, or if you don't have someone specifically dedicated to BIM, it's still really valuable to have those skills, because you could jump in and help solve problems where other people might be scratching their heads. You can get in the computer and use the power of BIM modeling to solve some of these really small problems. So it doesn't even have to be an entire project that you model. It could just be a very small part of the project, like one piece of the project. So, I think there's a lot of value for it, whatever you're working on.
And well, like you said, you don't necessarily have the all the tools that you need, but in the end of the day, you need to have understanding also the soft skills. You need to know what value. Because in the industry there's a huge debate, right? So what is over modeling and what's under modeling? And today, actually, we will discuss a little bit about that side as well. When we speak BIM for fabrication, there's a lot of over modeling going on over there. So people are really doing a lot of input, and then you don't need all those input points, and secondly, it increases the size of the project so much that you cannot really work around well. So you need to be really careful. As integrated BIM, we also work out of fabrication projects, so have a really good experience over there where you overmodel and you have huge problems, and you have undermodeling where you lack information. So it's a very good balance you need in between. I believe you will agree. And to do that balance, you need to have experience and the soft skills, basically, to understand what value BIM really brings. And so you model, as you said, specific items, or you just tackle BIM like authoring tools, any tools that you need for that specific purpose in order to get the most value out of it. So let's dive deeper into BIM for fabrication. We will speak after that mass timber and how to use mass timber in BIM and what benefits it brings. But before that, let's understand a little bit deeper into BIM for fabrication. When we say BIM for fabrication, what do you really mean? What kind of fabrication level we are talking about?
Yeah, so BIM for fabrication is LED 400 and above. So it's essentially it's enough information within the model that somebody could take could export from your model drawings or 3D files and fabricate those files and have them shipped to site and be installed with, I'd say there's a range of certainty on whether or not it's going to be actually match the model condition, So, there's a certain level of certainty of what you've modeled matching what's been fabricated and then matching what's installed, right? So, yeah. So that's modeling for fabrication is modeling with that in mind. Like, someone is going to use my model to fabricate from, not just use my model to coordinate and do clash detection, right? It's a big difference between.
Absolutely. So you need the stock lengths, you need the cut lengths, and you need to understand if there are certain miters, angles going on, what angles is being cut. So you have to have all this information in. And I think mainly one of the most important things are bill of materials for the fabrication, because you have a bill of materials which is very accurate, so you know what to order and obviously how to spare other waste because of your managing the stock. So can we dive deeper into understanding of that? So when you have, for example, BIM for fabrication, you did a very detailed model. And another question is, are you still using, before we move on that, are you still using LOD in United States?
Yes, we are. Are you not using that?
I mean, with the ISO 19650, obviously the industry is suggesting we should not use this anymore because it has been confusing the industry so much. And even we had a video about specifically with Marzia Bolpagni. She was talking about level of information need. So how did this change? How it was she did, I think, an entire dissertation on this. How that industry, or I think thesis, how the entire industry was actually getting confused with all this LOI, LOD, LOX, and LOG and all those stuff. So basically, so you're still sticking to LOD, and people are able to communicate when you say LOD 400. They're somewhat understanding what we need, or you still have some confusion over there?
Well, no, there's not. So what I've done in the past is we'll put together a design guide specifically to the project the scope of the project that we're working on. So in mass timber, for example, we put together a design guide with basically a pictorial and a textual description of what LOD was and what was included in the different level of details. So for mass timber, there was very specific requirements for different levels of level of detail. And so I think, because we were able to walk people through it specifically, because it is different for each scope of work too. I mean, level of detail in concrete is a lot different from level of detail in structural steel.
Correct.
So I can see why people are getting confused, because each scope of work is uniquely different.
Absolutely.
And when you talk about LOD 400 concrete, it's not the same as LOD 400 structural steel or mass timber.
Absolutely.
So, yeah, or mechanical, plumbing, electrical. So I can see why people are getting confused. But yes, we're still using LOD. I haven't heard anyone use anything different. So we're always a little slow to catch on to some of the BIM standards here.
I mean, ISO, I think I understand the move of ISO, why they do it. So it's like to make it more talking about what do we really need rather than focusing on just numbers. Because in reality, we never have LOD 400 if you think about it. It's always that there's some components that might be LOD 300, then some components might be 350, some components might be 400, some components can be even more than 400 over modeled because of certain purposes, like in order to get the right information. So.
Right.
Therefore, we always have a different number, and I understand that. The second thing that actually I want to dive deeper in the BIM for fabrication is that when you go for example, getting the bill of materials, and there's another question over here is that I can see in the chat, what software do you use? So how do you get bill of materials, all these, like cut lengths and all this stuff directly as a bill of material documentation, and as well getting the waste management? So how have you figured out your stock lengths and matching the right cuts and all this stuff? So can you explain us a little bit about your workflow, how you manage that workflow, and the software, obviously products, tools involved, a little bit about the process as well?
Sure. Yeah, so let me just, I think I'll need to start at the beginning. So kind of explaining, so mass timber is a structural system that uses wood with steel and concrete. It's kind of a hybrid composite system. So mass timber itself is just dimensional lumber that's been glued and pressed together, so laminated. So you have a column and beam system and floor decking system that's all made out of this engineered wood product. And then the composite factor is that it's typically connected to other materials. So the glue lam column would be connected to a concrete floor slab with a structural steel connection. And then on top of the timber floor deck, there's screws that are screwed in, and then there's a concrete topping slab that's poured over to give it a little bit more strength. So it's typically a hybrid system between concrete, structural steel, and mass timber. And so what we'll do is we'll start, when we initially engage in a project, we'll start modeling just the structural frame. So all the mass timber elements, the concrete, some of the architectural walls, and investigating the relationship between the timber components and the other building elements. So this is a very low level of detail model. We're just looking to make sure that there's no conflicts or clashes with other disparate materials. And then we start building in tolerances between different materials. So we'll look at how close is the timber floor deck to the CLT, to a vertical CLT wall, make sure that there's enough separation between the two so that it can be installed correctly. And then we look at the exterior condition. So we want to make sure that the timber slab deck, because it's a prefabricated element, we don't want to have to cut it or modify it on site. So we want to make sure that it works with the exterior facade system, and there's enough tolerance there so that we're not going outside of the building, the building limit or anything like that. And then what we'll do is we'll start working on, so the heart of what we do is in the structural connections, so the structural steel connections. So we're using Autodesk Revit. That's basically the only thing that we use for these fabrication models. So within the structural connections are our highest level of detail item. So they have all the bolts, the nuts, they have all of the welds. Sometimes we include shims and grout pad. So they're really, really high level of detail elements. And then those actually have void geometry that cuts the timber, because in order to fit together, the timber has to be cut to receive the structural steel connection. So we'll associate parametrically the void cut geometry with the geometry of the structural connection so that there's not a disconnect between the two elements, because typically those are fabricated by two separate suppliers. So we want to make sure that the information we're giving the steel supplier is matching the information we're giving the timber supplier, so that what's cut matches what's been fabricated so that they fit together. But as far as the timber elements, you're right. We never really get past a certain level of detail, because if we wanted to, we could model in all of the dimensional instabilities of the wood, because wood is one of the most dimensionally unstable building products. The width of a column could vary from 1/8 of an inch to 1/4 of an inch off, larger or smaller. So yeah, we're not getting into that level of detail with the columns. We're trying to control all the risk within the connection itself. So the other thing, I had another thought. The other thing that we do is we have to make sure that all of the timber is cut accurately, and then each unique individual element that's modeled has to be shown on a single piece drawing. So we'll take all of the unique timber columns and beams and the floor panels and all the structural steel connections. We'll put them all in single piece sheets. We'll dimension everything, and then that's typically what we send out as well as a 3D file to the fabricator for fabrication. So yeah, there is, kind of like what you said, you have to know where to put the detail. And on a mass timber project, the detail happens in the connections between columns and beams and floor decks. And then because there's typically a large number of fasteners on a project, we'll actually model the individual fasteners at certain points in the building, but then choose not to model the fasteners at other points in the building, where we could just use a simple text parameter to tell us how many screws there are, right? So yeah, you're kind of walking a line between, where do I want to show the information, where do we not need to show the information, because who's really going to look at it? Is somebody going to look at this project and want to look at each individual screw in a model? Probably not, right? So yeah, there is a line. So you have to know where the risk is, the construction risk, and focus your detail on that element where the most risk is. And on a mass timber project, that risk is in the connection, not in anything else.
Okay, that's a very good point. So I would like to dive deeper, and we have a few questions on that. One question is asking whether we can show samples, and I think it will be since we are directly live talk set up right now, it will not be able to. We will not be able to show any samples, but we'll try to explain as much as possible. The other question is, how do you analyze your connections after building it on Revit? So I believe this has two sides that we can understand it. One is, do you use this for structural purposes, like structural analysis purposes, these connections? And the other side is, how do you analyze like QA if they are right and you didn't miss any of the connections and it's inserted wrong, so you ship or you prefabricate the wrong items?
Yeah, so as far as structural analysis, we're not typically engaged on the project in the structural analysis phase. We typically get engaged to build the fabrication model when the structural engineer has mostly figured out what the connections look like. They don't necessarily need to give us the size of the individual plates, but if we have a sketch of what the connection is going to look like and how many fasteners are in it, we'll set up the connection parametrically, and then as the structural engineer gets a better idea of the size of this connection, we'll just change those parameters to change the dimensionality of the connection. When we do engage with structural engineers to come up with connection design, we actually use tools like Dynamo. So we'll use computational and generative design to iterate through different connection design options. And so rather than analyzing what we've modeled, we're creating a model out of our analysis, right? We'll run a structural analysis, and then the computer will automatically just model a structural connection for us. But then again, it's at a very low level of detail. It's basically just a sketch. And so we have to take that and turn it into something more parametric that's responding to the different parameters of the project. As far as QA/QC, it's all in documentation, right? Like I know a lot of BIM managers and modelers don't like to document their work on paper. But one of the reasons I really like Revit and I like using Revit is because it's very simple to create documentation as you go along the process. So a lot of the documentation I create never even gets to the client. It's mostly just for my own team to make sure that we've got everything correct. Because if you can see a dimension on a view of a project, it's correct, right? If you just have a parameter in a field somewhere, it's kind of hard to know if it's actually correct or not. And so very very early on in the project, we'll just start documenting things, creating detailed views and section views. Sometimes we use those to communicate with the client A lot of times we just use it to make sure that we're doing everything correctly. The other really important aspect is making sure that you're managing your family types and instances correctly. So making sure that you don't have rogue.
Very, very important.
Yeah, very important. So we'll actually start. We'll start a project, and we have a very specific naming nomenclature where the connections are associated with a particular column. And so what we'll do is we'll create a type for all of the columns, and we'll give that type a very specific type mark. And then we'll associate the connection that's placed on those columns with that type mark. So we know that this connection goes to these columns. And then, we follow that up with the project documentation. So we'll create a drafting view and tag all of those elements to make sure that we have every element where it's supposed to be associated with the proper column. And then we'll just keep purging the model so that we don't have elements that we're not using in the project, so we don't get confused. So Absolutely. Anything that's not actually placed in the project, we just get rid of on a weekly basis to make sure that we don't have any rogue connections. But yeah, that it's actually it's quite an intensive process. The modeling aspect it's only really half of the work. The other half of the work is just managing the project. Yeah.
That's true, especially when it's that level of detail. And in a second, we will dive deeper into a cloud collaboration of that and the lessons learned for the VDC. But before that, I just want to make a few points on that as well. So when you said, for example, connection, I presume in Revit, you don't use any plugins for like a kind of still connections, because the level of detail you're looking for, the information that you're looking for, I believe you need to do a manual process of parametric families where you can use with the help of Dynamo or kind of maybe some kind of sorting, so it can quickly insert it in multiple locations and multiple distances, or in certain cases, most probably you are adding things manually, and then there's a visual QA, and as you said, documentational QA aspect, documentational QA schedules, documentation to the information, most probably a lot of sections. I believe you're cutting a lot of things to understand if you're doing things right, and out of schedules already telling things are right or wrong. Most of the time when you visually just see it, you see, oh, this number is weird, it shouldn't be like that, or it's going beyond what we are expecting. But this is a power of Revit. Revit is very powerful in that aspect, and I think you're doing a right decision that you're using Revit, because if you use any other BIM authoring tool, I'm not sure if you can manage that level of efficiency for fabrication from the aspect. Maybe there are beneficials, like Tekla Structure is very good for structural aspect, for steel connections, but getting the family thing and getting those family thing documentation, very niche specific reasons, I think the Revit is best. It gives you the wider flexibility. What do you think on that aspect?
Yeah, absolutely. I mean, one of the reasons I just love Revit is because if you're willing to take the time to learn how to use some of the deeper functionality, you can really do anything you want. Whereas some of these other software, like Tekla you mentioned, and the timber industry, the mass timber industry actually has several specific mass timber softwares that you can use. It just lacks the functionality. It's really easy when you're doing connections that are predetermined, I guess, like pre-engineered hardware, or ho-hum connections that everybody has always used for many, many years. But when you're working on a project where you need a unique condition or connection, then Revit, it's really hard to beat Revit, because you can create anything. And then, yeah, like what you said, the data management is just phenomenal, the way that you can manage the data. We use a lot of global parameters in the project. So if you don't know,
and shared parameters.
Yeah, we use a lot of global and shared parameters. So we'll make sure that the parameters that we're creating within our family are shared parameters or global parameters. So we'll actually put kind of the high level information of a project as global parameters, and then we'll link all of those within the individual families. That's another really important QA.
It's a very, very important part. And one thing before I jump in the next topic, I would like to make a point here is, this is really important, like specifically for the audience. When we do, especially like, let's talk about Revit and we are going fabrication level of detailing, we figure it out the right components. So when we have, for example, this component that I'm looking for, we might need all the screws, all the information, the quantities, but they don't necessarily have to have this complex geometry modeling. You can find different approaches, different ways how we can insert this information. So an amount of that information by some kind of logarithmic or a parametric way, and then you will get this information at the project level in the documentation and in your bill of information, bill of materials. But obviously, when you zoom into the model, you might not see that level of detail. So you might see another object or just rectangular piece there, or maybe even no piece at all. So I believe Joshua is also using a lot of these kind of techniques in order to lessen the weight models, because most probably his families are all the time getting higher and higher in weight because of a lot of functionalities. So he has to think of workarounds and do simplifications like this. And maybe just mention it very quickly on this, and then we just move on to cloud collaboration.
Sure. Yeah. So sometimes, so first off, a note about screws. We do model a lot of screws, but we never model threads. And I've seen a lot of people get really spun up about modeling threads, but you don't need to model threads. So we typically we show a cylinder with a tip, and then if it's a countersunk head, we'll show the countersink head so that we know that we're pre-drilling the steel correctly. But that's as high level as we go. We'll get the length correct, the diameter of the screw, but we're not going to go into more level detail. Sometimes we just have cylindrical objects, just round cylinders that show the length of the screw. But a lot of times, we have these connections that connect to, like, for example, most panels are 40 feet long, and there's a piece of plywood that connects the two panels together, and then there's screws that go into the plywood at like 12 inches on center. And with an element like that, if you want to schedule how many screws you're going to need per cut, you just take the length of the panel and multiply it by 12 inches or divide it by 12 inches, and that's going to give you your screw count. You don't have to model the screws. You could just create a parameter that divides the length of the panel by the spacing of the screws, and it'll give you a quantity of screws, and you can schedule that in a schedule. So it's, you really need to know where to apply the detail, where to lay off on the detail, because it's a matter of time too. You don't want to take the time to model something that's not going to give you any value, because nobody wants to pay for that, and it's just going to create this, this time drain on your team, and it's an expense that the client doesn't really need, and so you need to walk a line between where to put the detail, where to leave the detail out.
All right. So actually, I just got a comment here. Kai Corinth, he's disagreeing with the workflow using Revit for timber connections. He was like saying they are far more superior for European industry, but generally Joshua and our team as well, Integrated BIM, our client base is like 90%, I would say 80 to 90% in US. So, and I think Joshua is 100% in US. So
yeah, I do work with clients in Canada.
Okay.
But yeah, it's mostly Canadian, United States, and it is different in Europe, because in Europe, mass timber has been around for quite a bit longer, and the codes are a little bit different, and so a lot of the timber connections are a lot more standardized there than they are here. And when you're working with a standardized product, it's a lot easier to create a piece of software that just does that for you. But even in the United States, as we've become more standardized, because we've been using tools like Revit for so long, I really think that trend is going to continue, because we don't need a very specific piece of software to do these timber buildings. And the advantage of using Revit is that it's the product that the architect and engineer are most often using, at least in the United States. And so we're speaking the same language, and we're doing the cloud collaboration. It's really easy to collaborate in the cloud.
Yeah, can you just dive deeper into that as well? So this is the next thing that I would like to open a topic on. So the cloud collaboration, which Revit allows, because I understand the point of view actually why they raised this question, because why don't you use niche software? The reason that I think we stick with Revit on this kind of, like, especially for our team, I would say for Revit, for fabrication, because we can innovate our own process. So just to explain what does it mean, there's a model, building information model, and there's a modeling. The modeling can be many different ways, and this is if you use a standardized tool, like a specific tool for mass timber or timber construction, you have to stick with the limitation of that software. With Revit, you have a much wider limitation. Like it is like much wider. You can just use out of your innovation or like different ideas of processes, and you can implement inside Revit. So that is one of the main reasons I think we are sticking with it. So it gives us a little more flexibility of creating our own process that will work for a particular team of structure. Maybe you can answer this, add to anything to this, and together with the cloud collaboration.
Yeah, so I mean, very specific project that I worked on, and it was with a European supplier, and we had sent out quotes to different European detailers, and we kept getting a time frame of 10 months, 11 months, like it was going to take them that long to model the project. And we were able to complete the project using Revit in 3 months because we set up the project kind of like what you were saying. We set up the project in a very custom way, and it was very specific to this unique project. And so the reason that they were saying 10 months, 11 months in this project was because it was still they were still kind of iterating through the design. A lot of things kept changing. And so, but we understood what was changing on the project. And so we set up all these parametric relationships with the architectural model. And because we're using Revit, we can link, via the cloud, we can link the architectural model to our model. And so every time they updated their model or published their model, it would bring their model into our model, and it would adjust and update our elements parametrically to that model. And so if their column sizes grew larger, our connections would grow larger. If they changed the grid spacing, our grids would change and all of our columns and beams would shift. But
because you associate them together, right? You link those information together.
Yeah, I link them together, right? But the other timber suppliers that were using the more niche software basically had to start their model over each time there was a change. They just
modify depending on the amount of change there is. Right.
But we don't. Yeah, but using Revit, you can set up a Revit project so that you don't have to manually modify anything. You could set it up so that you could use Dynamo to input data, change parameters, or link a model so that if the architect changes things or the structural engineer changes things, your model just updates automatically. So there's a lot more flexibility, and it helps you work. It helps you work with the design team in a much more integrated way. It's kind of breaking down the barriers between architecture and construction. It's moving more towards a digital integrated project delivery approach rather than design bid build approach. So.
Yeah, I understand. Actually, that's a very important point because I love the idea of open BIM. There is definitely the open BIM is very important because multiple vendors competition means that everyone will try to improve their product all the time. So which will be better for the end users in the end of the day. So there's not one vendor leading like right now in the industry. So but the good thing over here is that, for example, with our like niche specific software, when you have this cloud collaboration, like you said, you can automate a lot of the procedures of the workflow, which with the OpenBIM would have been much more difficult because you can overlay the information, you can do the clash detection, but you cannot set parameters of the changes to change your own models. That will be missing. So you can use a certain software, export the like in OpenBIM IFC format, link it or directly link it in the cloud. All the models are linked in the cloud, but parameter size changes will not occur in individual models directly. So that is a benefit of niche platform and niche specific like Revit and Autodesk Cloud, where you can do this kind of linking if everyone uses Revit. The question over here is if the other people are not using Revit, then you have like the same problem again with Revit that you cannot automatically link. So how do you manage the stakeholders in that way? So do they have to use Revit for sure, or
No, so the only people that we're really interested in being parametrically associated with are the architect, construction engineer, and I would say 100% of the time, 100% of the projects I've ever worked on have been Revit projects. If the steel supplier is working in Tekla, I don't really care, because they usually take so much time to model the steel that we just model it anyway, so that we can do our own clash within our own model with the steel elements, because they might get us their steel model a week before we need to give drawings out, and that's just not enough time to do all of the clash detection with the steel model. So we'll just do it. It's kind of the same thing with concrete wall framing. We don't. And that's another advantage of using Revit, is that you can create all those different building elements within Revit really simply. It's a piece of software that's designed to be able to create walls, floors, structural steel, structural concrete. It's kind of a jack of all trades, master of none type software. So
we will be diving deeper now into BIM Career and VDC Career and the lessons learned by Joshua, and then he will have a BIM Advice, do's and don'ts for your career and obviously in your projects. And I will be trying to answer a few other questions you have on the way. So just list them down, all the questions that you have, because we will come to Q&A session within 5 minutes, literally. So can you tell us a little bit more about the VDC and BIM Career and learned lessons that you have, like major lessons maybe?
Yeah, so in the United States, at least, it's fairly new. VD&C has only been around since, well, I've only noticed VD&C being around for the past 5 years. Before that, it was all BIM. So virtual design and construction kind of came about 5 years ago. I don't really know what the impetus was, but that the people that used to be BIM managers or BIM engineers became VD&C managers or VD&C engineers.
What is the difference?
Yeah, so building information modeling, right, is the technique, or not the technique, but it's the system, or the methodology, of creating a 3D model with information associated with it. Virtual design and construction, to me, I feel like is more about using the BIM methodology to solve construction specific problems. So like
it's the same thing.
Yeah, it seems like the same thing. So I don't know how to describe the difference. All I know is that the nomenclature has changed, and the perception has changed, because when things were just BIM coordination, it was just taking everybody's model, running clash detection, creating clash detection reports, moving model elements, and that was kind of the perception in the industry before, was that was all you could do with BIM and modeling. But now it's more of, we can actually use models to build projects. And I think that's why the nomenclature has changed. Like it's virtual design and construction. Like we're going to actually build from this model, not just play around with it and do clash detection. Not that that's not important, but clash detection is only one aspect of using BIM. So
my observation on that actually is a little different. First, I find VDC a little more fancy in comparison to BIM Manager. And second thing, I think VDC is a little interesting because a lot of people, like when you say BIM, they say, what is BIM? Then you say building information modeling. They say, what is building information modeling? Then you explain the theory behind it, that it is like there are tools, processes, and policies involved. So like standards and the way you approach and the like different technology you're using. But virtual design and construction, when you say, I never heard like a response. What is it? They're understanding. Okay, you are, rather than doing it in a like a traditional means, you're trying to do it in a digital, like virtual way, and trying to do like taking all your traditional workflows into digitally. So it doesn't necessarily mean that you use BIM authoring tools. It could mean that you use AutoCAD, but just in a digital environment. So basically, in a more collaborative environment. So that is, I think, I like the bit on that part, like it's being fancy on one side and giving a little more clarification in comparison to BIM. But apart from the other side,
it's really about clarification. Yeah, I agree with you. Yeah,
because go ahead.
My definition isn't that great, so I like what you said.
I mean, I read I read in one book. I think it was written by Holzer. The BIM Manager. The book calls the BIM Manager, and it was like first page was saying, I'm like. I don't know exact the quote, so but I will just try to say it. I'm writing this book to my architect wife who doesn't know what BIM is, like so explaining like the BIM is very difficult to explain. But yeah, so it's great that that we try to find different variations. But can you tell me a little lessons learned in the industry, like in your career? What lessons you learned specifically that impacted your career?
Yeah, so I think from a BIM and VDC perspective, I think there's too few BIM managers and VDC managers that understand or that want to understand construction, like how these things are actually built. But I think that really enhances your ability to manage a project digitally.
Absolutely.
Yeah. So I think one of my major lessons learned, and maybe this is because I originally came from the construction industry. So I was, my career started off in the field as a carpenter, but then, I transitioned into BIM, VDC. So, I would say there needs to be less of a focus on, because, you go to conferences every year, or you follow forums or online publications that cover BIM and VDC. And a lot of the time it's talking about the greatest and latest breathtaking technology that's being introduced, right? Which is wonderful. I'm all for advancement in technology and software and hardware. But if you don't understand why we're using the software, then it really becomes like AR, for example, augmented reality. I've seen that marketed up, down, and sideways to architects. But the feedback that I always hear from architects is we don't need augmented reality because our models never look as good as our renderings or as our as our presentation graphics, whatever. Augmented reality is more useful for the person like a construction manager who wants to make sure that everything's fitting up in the MEP raceway in a building, or the underground pipe is being laid correctly according to what's been modeled. So sometimes there's a disconnect between the technologies that are being developed and what they're being developed for. And so I think, working with virtual design and construction, it's important to understand what people are getting out of the model. What's the end result? Who are the end users, and what are they looking for? So yeah, I mean that's one of my biggest lessons there. Is just not to get sidetracked by using technology for technology's sake. We need to know how to use technology to actually provide value on a building project, not just to use technology just to use it.
It's very very well said, because and I think one of the main things that industry needs to understand, that if you want to be a VDC manager or BIM manager, I think as a theory they are quite the same thing. So but in the end of the day, if you want to be going in the management role or try to do something more than technical modeling, you need to understand a few things. First of all, you need to understand the soft skills. You need to understand what really the core principles of BIM, and you need to really be motivated with them because if you're not motivated yourself, how can you drive the entire team or people and so forth? Secondly, you need to be a little bit more adaptive. So you need to find innovative solutions, because you can know how to use a tool, you can know the soft skills, but if you cannot connect them analytically in your mind, you will not find a solution. You don't know, okay, do I use sweep here or revolve here? How do I solve this? You will not find it. You know how to use sweep, you know how to revolve, but you will not know how to solve that problem. So, and industry is paying you for solving problems. So that's the truth. They say they are literally paying you to solve the problems. The more problems you solve, the more wealth you will get. So in order to solve the problems, you need to understand the construction, like Joshua said. You need to understand the soft skill of BIM and the virtual design construction, basically, as we just said, the theories. And you will need to understand the technical aspect, the authoring tools, and to get advanced, diving deeper to core functionalities. Actually, when I say core functionalities, it's not the essentials or the basics, but diving deeper in understanding how the code works, how the software kind of thinks when you sending information to the software so you can solve and create innovative ideas. So let's have a do's and don'ts from you as an advice, so that our audience can take it home together with them.
Yeah, do's and don'ts. I'd say, don't get so wrapped up in a technical problem that it just absorbs you for 10, 20 hours. Step back and reevaluate why you're trying to solve this technical problem. Like the screw threads, for example. I've seen so many people spend so much time trying to model accurate screw threads when there's probably better tools for that. And second, you probably just don't even need it in your model. But I'd say focus on the end results, kind of like what you said, solving problems. Am I solving problems? And am I helping to generate revenue for my client? Am I helping them to reduce risk on their project, or am I just modeling something for fun? So those are my do and my don't.
I will add something to that, and they're really very good advices that you just gave. But I think people should listen and take this advice, guys and girls. Don't over model. Don't over model. You're killing the purpose of BIM. BIM is it is getting the value in return of your investment. So if you're over modeling, it's on its own the name. It's just waste. So don't go on the waste side. It's just you should use this tool to help you to eliminate waste and not to create extra waste. And in the industry, there's a tend to have our number one thing in each project. We do kickoff meeting and we just bring on a table, how can we eliminate double the work? So I don't want to model something that someone else does, or how can we eliminate that? So we don't want to create waste, because this brings value to everyone. So you need to understand that, we need to avoid that, and then we can bring benefits to everyone. So imagine that you're doing double the work, I'm doing the double the work, she's doing double the work, and what happens in the industry? So you don't get the real benefit that we are looking for. So this is one advice that I would like to give you today. So thank you very much, Joshua, for coming over. It was absolute great, you're a great guest, and I think there's a lot of value in this conversation. I'm not seeing any more questions in the, so I can answer some things. There are one question here that, what sort of services I can offer as a BIM designer? I don't understand exactly what BIM designer mean. Probably BIM technician, you mean, like someone who is using BIM authoring tools for technical purposes, modeling and so forth. You want to answer that quickly, and I read if there are any other questions in the meantime?
Yeah, really quick. I mean, there's a number of things you can offer. BIM coordination is a big one. So just being able to manage a project for someone like a general contractor, being able to, not model, but take the work that everyone's done, organize it in such a way that you can, clearly see what's going on, where the clashes might be, and the best way to solve problems. The other way is by modeling yourself. So creating BIM models for BIM coordination. So like working with mechanical, electrical, plumbing, fire protection services groups who primarily model just for the coordination purposes. And then, the other service is working for specialty subcontractors, helping them create layout and shop drawings out of the model. Kind of like what we've been talking about today. The other service is providing services for architects and engineers. A lot of times engineers especially don't want to manage a model. They don't want to manage their documentation. And so they'll outsource a lot of model management and documentation to a third party. And I've worked with a lot of engineers in this capacity. I think architects are at the bottom of this list. I've never worked much with architects, but that's because I don't specialize in, the advanced rendering or graphics processing, but that's another avenue, is working with design teams to represent their project architecturally is what they're interested in. So there's a lot of different people you could work for. I mean, you could even work for a material supplier who wants to create Revit families for architects to use. Like a plumbing
BIM objects are.
Yeah, BIM objects. Yeah, you can create BIM objects for different material suppliers and vendors.
Did you realize Joshua's feedback? Like every single time he said something, he said, and even he said that he didn't want to, he didn't do any collaboration directly with architects providing services. The main reason behind it that he doesn't have the professional experience and maybe knowledge of how to collaborate directly with architects and what they are really needing it. So if you take BIM on its own and you just know BIM, like maybe some soft skills and technical skills, you are no use. I mean, you're not bringing really benefit. Joshua really brings benefit because he has carpenter skills. He knows how things work on site. He has been doing this again and again. He understands the construction, and then he brings the most value out there. If he was more on the design side, he would have been working, maybe most probably collaborating with more architects and designers. So the core thing over here is that you need to really understand the constructability and construction things, and then add BIM on top of to improve the current practices. If you just have BIM on your table and you don't understand the construction, it will not work. I'm sorry. It will literally, you will not bring in value apart from over modeling and under modeling, because you will not understand even what's over, what's under.
Yeah, right. Exactly.
All right. So great. Once again, thank you very much, Joshua. It was awesome talk, and I really appreciate your being a guest here. And I hope today's audience took a lot of information and valuable knowledge. Next week at this time, we are having a new BIM talk. So at the same time, I'm really looking forward to all of you, and we'll have another lovely conversation. And wish you a lovely day.
Okay, thank you.